Alright guys, what I want to talk about first today is to go over a couple homework problems from the fundamental theorem of calculus and indefinite integral assignment. And so first let's take a look at number 6. Alright, so over here, alright, so number 6, let's take a look at this one. Alright, so on number 6, what makes this difficult is you have to convert it to this power notation. So the first step is rewriting the integral in power form. So I have the integral of 24 x to the 1/2 and then plus, now this is another power of x, and since it's in the denominator, it's going to be negative. And then it's the 7th root, and x is to the first power, so it's the 1/7. And this is dx. Okay, once I have it in power form, it's pretty simple to solve. I add 1 to the power and divide by it. So this is equal to 24 x to the 1/2 plus 1, and then divide by it. So 1/2 plus 1, and then plus x to the minus 1/7, add 1, and divide by it. So minus 1/7, and of course plus c. And then the rest is just some arithmetic. So I add 1/2 and 1, so I get 24. X to the 1/2 plus 1 is 3/2. So then I divide by the same thing, 3/2. And then plus minus 1/7 plus 1 leaves me with 6/7. Right, so I have 6/7 on top here. And then on the bottom, I have the same thing, 6/7. And so this is equal to, I can multiply by the reciprocal. So I'm going to multiply 24 by 2/3. So I'm going to get 48/3. Right, x to the 3/2. Plus, multiply by the reciprocal, so I get 7/6, x to the 7/6. And I forgot to write my plus c here, right? So I should have plus c. All right. I guess I should simplify 48/3. 48/3 is 16. So I have 16 x to the 3/2 plus 7/6, x to the 7/6 plus c. Now you can leave it like that, or if you like, you can put this back into radical form. This would be 16. This would actually be x squared, square root of x, plus 7/6. And now this would actually be x times the 6th root of x plus c. Right, to see this last part, right, realize x to the 7/6 is the same thing as the 6th root of x to the 7th, which then can be written as the 6th root of x to the 6 times x, right, to the 1, I guess. So exponents add here, so that's how you get back the 7. And so this is actually, remember, radicals go through multiplication and division, but not addition and subtraction. So this is the 6th root of x to the 6 times the 6th root of x, and the 6th root of x to the 6 is just your x, and so you get x 6th root of x. All right, but you can leave your answer like this right here. All right, the next one I want to look at is number 7. So let's take a look here at number 7. All right, so on number 7, I have an exponential function. And so on this one, I have an exponential function. It actually falls out pretty straight forward. This is an integral of 5x plus e to the x times dx. And so what I have is 5x squared over 2 plus, and the integral of e to the x is just e to the x. So e to the x, and then plus a c. which is similar to the next one I want to look at. So let's look at this the next one here, number 11. All right, so on number 11, we have, instead of an indefinite integral, we're going to do a definite integral. So right here on number 11, and we'll just paste it right here. All right, it's almost the same problem, except you have now numbers, right? Limits of integration right here. And so to do this one, it's really the same steps. So you have to first integrate 4x, so that's 4x squared over 2, minus the integral of e to the x is e to the x, but instead of doing plus c, we have limits we put on here, so it goes from -1 to 0. And I can simplify this a little bit because 2's will cancel here, so if I take 4 divided by 2, that's 2, so I get 2x squared minus e to the x, all from -1 to 0. And so then I plug in the upper limit. So first I plug in 0. So what do I get out? I get 2 times 0 squared minus e to the 0. Now here you have to be careful, right? E to the 0 is not 0. It's actually 1, although this is 0 there. Minus, now plug in -1. So 2 times -1 squared minus an e to the -1. And so for my answer, what I have is minus 1, right, from this thing. I have 0 minus e to the 0, which is -1, minus a 2 minus e to the -1. And so that's equal to a -1, a -2, and a minus is a plus e to the -1, which is simply equal to e to the -1 is 1 over e, and then I have -1 minus 2, which is -3. And so you can see here the answer is 1 over e minus 3. And the last one I want to do is number 13. So on this one, what do we have? So this one's going to involve an ln. Alright, so I have the integral from 1 to 3 of 6x squared plus x to the -1. So here you have to be a little bit careful. Let me show you the mistake students typically make. Right, they typically say, okay, this is equal to, so I add 1 to the power, and I divide by it. Great. And I add 1 to the power, and I divide by it. Not so great. And I go from 1 to 3. Not so great because when I try to simplify this, when I do the arithmetic, I get 0 in the denominator. That means I did this wrong. So I have to go back and figure out exactly what my mistake was. And my mistake was that I didn't realize that this is one of my 4 types. Right? This is actually the integral from 1 to 3 of 6x squared plus 1 over x. Right? That's what x to the -1 is. And the integral of 1 over x is ln of absolute value of x. And so this is actually equal to 6 divided by 3 is 2, so I get 2 x cubed plus ln absolute value of x plus a 1, from 1 to 3. And so this is equal to, I take 2, 3 cubed is a 27, so 2 times 27, right, plus ln of absolute value of 3, so just ln of 3, minus just 2, because then I plug in the 1, right, so that's just 2. And then plus ln of absolute value of 1, which is just ln of 1. Of course, ln of 1 is 0. So this is going to be equal to 2 times 27, which is a 54, plus ln of 3 minus 2, which equals 52, plus ln of 3. And that's the same answer we have above here. All right, so today's lecture, what we want to talk about is a type of integration technique, which is called integration by substitution. So if you look on the slide on the right, what it says is how do we integrate this thing? Right, so how are we going to integrate 2x times the quantity x squared minus 1 to the 10th power dx? And the idea is we're going to make a substitution that's going to turn it into one of our 4 types. So let me remind you what are our 4 types. So we have an integral of a constant, dx is equal to a constant times x plus c. And then we have the integral of a power of x. All right, so the integral of x to the n, right? The integral of x to the n dx is equal to, you add 1 to it, so n plus 1, and you divide by it, n plus 1 plus c. And we have to remember n can't be equal to -1, because that's going to be taken care of in the fourth case down here. And the third type is the integral of e to the x dx. Right? The integral of this is just e to the x plus c. And finally, the integral of 1 over x, so this is when n is equal to -1, dx is equal to ln and then the nasty absolute value of x plus c. All right, so these are our 4 types. And so if we want to integrate something, we have to turn it into one of these 4 types so we can get rid of basically this integral sign, this s, and this dx. And that's the only way we can do this. And so how can we integrate this? And so what we're going to do is we're going to use a technique, a method that is called integration by substitution. So what is integration by substitution? All right, let's look at an example. All right, so our first example, which is going to be just what we had before. So example 1, we want to find the following indefinite integral. I'm going to take part A, the integral of 2x, right, just the one we had before, x squared minus 1 to the 10th dx. And so I want to explain to you what this integration by substitution is. And the idea is you're going to make a substitution. So we're going to let a letter u, and we'll always use u, and we're going to let it equal something over here. And the idea, right, there are 2 ways to think about this. So let's look at a slide here. So the trick is you can let u be the thing on the inside, or look for a function and its derivative. All right, so let's think about the thing on the inside. So if I said let u be the thing on the inside, you have 2 choices, right? Which one would you choose? It's either the 2x or the x squared minus 1 to the x squared minus 1. Which one is the thing on the inside? Well, obviously the x squared minus 1. And if you choose that, you'll be okay, because when you take a derivative, so the idea is differentiate both sides. So we'll write du equals, and take the derivative of x squared minus 1. And so you get 2x, and then you write dx on this side. All right, so du is equal to 2x, and you write dx over here. You're going to be able then to substitute back in and get your answer. All right, so this is going to equal, and let me change colors here. So what I'm going to do is I'm going to find my u. So here's my u right there. So there's my u. Oh, and let's use, instead of a circle, let me use a box. So here's my u. All right, so where I see x squared minus 1, I'm going to write a u. All right, so I have an integral, and I have my u here. So this is u to the 10th. And then I have this 2x dx, but that's right here. So 2x dx, right, this 2x dx, this is the same thing as that. So where I see this, I can just replace that with du. So I made a substitution. I let u be x squared minus 1, and the derivative of u is 2x, and I write dx on this side. I mean, the idea here is actually you're saying, you know, du over dx is equal to 2x. That's dx. And then you're just multiplying both sides by dx to get du equal to 2x dx. And that's sort of the idea. But typically we just do this all in one step. Du equals 2x dx. And then we just substitute back in, just replace the things. And then I can integrate u to the 10th. It's just a power rule, right? You add 1. So that's u to the 11th divided by 11 plus c. And then I resubstitute back in, right? So I plug back in for u, and so I get my final answer of x squared plus 1 to the 10th, all plus c. Oops, not to the 10th. All right, to the 11th. All right, so to the 11th divided by 11 plus c. Now let's do another one. So let's look at the next one and see if we can make sense of it. And so we have the integral of 3x squared e to the x cubed dx. And so on this one, all right, what do we want to do? Okay, so again, I want to make a substitution. And the idea is let u be the thing on the inside, or you can think of it, do you see a function in its derivative? Right? If you like the thing on the inside, and you say, okay, well, x cubed's on the inside, then you'd be right. Or you'd say, do I see a function in its derivative? Well, I have 3x squared, its derivative is 6x, I don't see that anywhere. Or I have x cubed, and its derivative is 3x squared. So that's the one I want to choose. So I have x cubed here, and its derivative, du, is equal to 3x squared. And now I'm going to substitute back in. Right, I'm going to substitute in for x cubed. So here's my x cubed, right? And that's my u. Right, here's my x cubed, and that's equal to u. And then over here, this is my du. Oops, I forgot to write dx over here. Right, make sure you write dx. Right, so this is my du. And so this is equal to the integral of, I have e to the u, and 3x squared dx is just to e to the u. And this, again, it's one of my 4 types. Right? It looks just like this. Right? If I don't have to write an x here, this could be a u. It's the same thing. So the integral of e to the u du is just equal to e to the u plus c. And then I substitute back in here for the u, and so I get e to the x cubed plus c. Let's fix that stupid u. All right, so that's e to the x cubed, there we go, plus c. And that's my answer. Now you can check these, right? Up here I could check this one, take the derivative, 11 would come down, they'd cancel, x squared plus 1 to the 10th, times the derivative of the inside, 2x plus 0, so I get it back. Here, same idea, e to the x cubed, derivative of e to the x cubed is e to the x cubed, times the derivative of the inside, which is 3x squared, and plus 0, so they check out. All right. Let's take a break here, so you can pause the video if you want, and try the group work, and then just do part A, and then when you come back, I'll go over it with you. So take a minute, try to do part A on the group work, and then I'll go through it with you. And I'll tell you the answer here. So on the group work, so you know if you got it right or not. All right, so we have the integral of 3x squared times x cubed minus 7 to the 4th power dx. Right, after you go through this, you should get this to be equal to x cubed minus 7 to the 5th power divided by 5 plus c. All right, so take a minute and try to do this problem. All right, so hopefully you tried this, and what you should do is you should make your u substitution. So let's let u equal the thing on the inside, or you say here's the function, there's its derivative. So u is equal to x cubed minus 7, and in this case then du is equal to 3x squared dx, right? So take the derivative of this, and then you plug back in. So let's change colors up here. So this is my u. Here's my u right there. And then this piece, this 3x squared dx, okay, that's right here, and that's my du. So I just plug back in, and so this is going to be equal to the integral of u to the fourth. Let's move this up. All right, so this is going to be equal to the integral of u to the fourth. All right, and then here, this is my du. All right, so 3x squared dx is just my du. Now this is just a power of u, which I can integrate. I add 1 to it, so u to the fifth divided by 5. Make sure you say plus c. And then I resubstitute in for the u, so use x cubed minus 7, so I have x cubed minus 7 right here to the fifth power divided by 5 plus c. Right, and this was part A, right, number 1, part A. Okay, and so the next thing we want to talk about, next example, let's look at these, the next set. They're a little bit different. All right, so on here, what I have for example 2, let's see how they're different. All right, part A, I have the integral of x times x squared minus 1 to the 10th dx. All right, I'm going to use substitution, right, the integration by substitution. All right, so I have to figure out, okay, what am I going to make my u? And I have two choices. I can let it be x or x squared minus 1. If you try to let it be x, you won't get anywhere. And so it's this thing on the inside, right, this x squared minus 1. And so I take the derivative du, and that's equal to 2x times dx. And I go to substitute back in. All right, so here's my u. But I have a problem. Right, here I just have x times dx. And I do not have the 2x dx. But it's really not that big a deal because I can get rid of this 2. I can move it over. How can I move it over? Well, I'm multiplying, so I just divide. So this is du over 2 is equal to x dx. Right, so now, here's my x dx. I can just plug this in, du over 2 for the x dx. So this is equal to, I have u to the 10th, so x squared minus 1 is my u to the 10th, and x dx is du divided by 2. And then I can do a little bit of algebra here if you like, and just move the 1/2 outside the integral sign. It's probably the easiest way to do it. So that's 1/2 the integral of u to the 10th du, and that's just a power of u, so I add 1 to it and I divide. So 1/2 u to the 11 over 11 plus c, which is equal to u to the 11th divided by, right, 2 times 11, which is a 22, plus c, right, which is just equal to, plug back in, so I have x squared minus 1 all to the 11th. Okay, that was my u, all divided by 22 plus c. And that's my answer. On the next one, part B, I have the integral of e to the 7x dx. All right, so now I look at this with fresh eyes, right? I say, okay, it's not one of my 4 types, right? One of my 4 types being a constant, a power, just e to the x, or 1 over x. All right, so there's not much I can do with it as it is now. So what I need to do is I need to make a substitution. So I have to let u equal, and there's only one thing it can be equal to, and that's 7x. So u is 7x, and then du is equal to 7 dx. And so I come back over here, and let's see if I can identify my part. So that's going to be my u. That's easy. And then all I have left over is this dx part. And I don't have dx over here. I have 7 dx, but that's okay because I can move over the 7. I can just divide both sides by 7. And so du over 7 is dx. And I can just plug in here. So this is equal to the integral of e to the u, because that's 7x. And then dx is du over 7. And the easiest way to integrate this is just pull out the 1/7. When you divide by 7, it's the same as multiplying by 1/7. The integral of e to the u du, which is equal to integral of e to the u is e to the u, right, of course, times 1/7, so divided by that 1/7 plus c. And then plug back in for u, and so that's e to the 7x Again, u is 7x divided by 7 plus c. And remember, you can check your answers here. It just becomes a little bit harder because the functions are harder. So like if you want to check your answer, take the derivative of this thing. So the derivative of e to the 7x divided by 7 is e to the 7x times the derivative of the inside, which is 7. So 7's cancel, plus 0, and you just get e to the 7x back. All right, so let's do the next group work problem. So I'll write it down here, and then you can pause the video and work on it yourself. So part B, on this one, all right, what do we have? Well, we have the integral of e to the 5x dx. All right, so make your substitution, and you should get out for an answer. This should be equal to 1/5 e to the 5x plus c. And once you finish that one, you can continue on and try the next one, part C. All right, so try this one too. So the integral of x divided by x squared minus 1 dx. And for this one, you should get an answer of 1/2 ln absolute value of x squared minus 1 all plus c. So pause the video and try these two, and then come back when you're done. All right, so on part B, you're going to make a u substitution. So you're going to let u equal, and it's just going to be the 5x. That's really your only choice, so 5x. And then du is equal to 5 dx. Right, derivative of x is 1, so you just get the dx back. And so we're going to get this to be equal to, and we can see here's the u, right here. There's my u. But then I just have dx left. Right, and over here I have 5 dx, but that's okay. I can divide both sides by 5, so du divided by 5 is equal to dx. And then I can make my substitution. So this is going to be equal to the integral of e to the u times du over 5. And I can pull out the 1/5. Right, so pull out that 5 in the denominator. So I get 1/5 the integral of e to the u du, which equals 1/5 e to the u, because the integral of e to the u is e to the u, plus c. And I substitute back in, so u is 5x, so I put a 5x where I see a u, and I get my answer. The next one's a little harder. So on this one, I have two choices. I can let u be x, or I can let u be x squared minus 1. If you let u be equal to x, you'll get the same thing back, so it's not going to help you. So I let u be equal to x squared minus 1. And then du is equal to 2x dx. All right, so here's my u, so no problem there. I have my u. But here, I have x dx, right? And over here, I have 2x dx. And so what I need to do is I need to figure out, how can I turn this into x dx? And it's real simple. I just divide both sides by 2. I get du over 2 equals x dx. So when I come back over here, and before maybe I substitute back in, maybe it'll be easier if I write it like this, as the integral as 1 over x squared minus 1 times x dx. Right? That's the same thing as above, right? Remember, basic algebra and arithmetic. If I have 2/3, that's the same as 1/3 times 2. That's all I'm doing here. I separate the fraction, but it makes it a little bit easier for me to see that here's my u, of course. There's my u. And then this x dx is my what? Well, it's just my x dx right here, my du over 2. So I substitute back in. This is equal to the integral of 1 over u du over 2. because that was x dx. I can pull out the 1/2, so I can write this as 1/2 the integral of 1 over u du. And I can integrate 1 over u. It's one of my 4 types. So this is 1/2 ln of absolute value of u plus c. And now I substitute back in for u, so u is x squared minus 1, so I have 1/2 ln of absolute value of x squared minus 1 plus c. All right, so in the last one we're going to do together, so let's do part D together. So on here, part D, this one, I have the integral of x cubed, and then I have a square root, and 2x to the 4th, and then minus 1 with the dx on the end. And so again, I can make my u. You have 2 choices really, x cubed or 2x to the 4th minus 1. If you let it be x cubed, the derivative of x cubed is 3x squared. I don't have that anywhere. But if you let it be 2 times x to the 4th minus 1, its derivative is 8x cubed, which is almost x cubed, right? And you can be off by a constant because we can divide it out. So this one's going to be 2x to the 4th minus 1, and then du is going to equal 8x cubed dx. Right? And I can already see I'm going to have to move over that 8. Right? Du over 8 is equal to x cubed dx because I do not have an 8 in front of the x cubed. So when I go back to substitute in for 2x to the 4th minus 1, when I come back here, what I see is I see that this is a u. Great. And then this thing, x cubed dx, right, so here's my u, and that x cubed dx is actually du over 8. So this is equal to the integral of u, and it's square root, so I'll put u to the 1/2, and x cubed dx is du over 8, and that's equal to, you can pull out the 8, so that's 1/8 the integral of u to the 1/2 du. And this is just a power of u, so I add 1 and I divide by it. So this is 1/8 u to the 1/2 plus 1 divided by 1/2 plus 1, right, plus c, which is equal to 1/8 u to the 1/2 plus 1, that's 3/2, right? Half a cup plus 1 cup is 3/2 of a cup. And then divided by 3/2 plus c. And on here, now I'm going to divide by a fraction, so I multiply by the reciprocal. So this is going to be equal to 1/8 times 2/3 u to the 3/2 plus c, and I can simplify this a little bit, right? 2's will cancel here, so if I cancel this with this, I get 4, and so this is going to be 1/12, 4 times 3, u to the 3/2 plus c, and I plug back in for u, so u's 2 times x to the 4th minus 1, so I have 1 over 12, times 2x to the 4th minus 1, all raised to the 3/2, let's raise to the 3/2, plus c. And that's my answer. All right, next time when you come back on Friday, what we'll do is we'll lecture about how we use the fundamental theorem and integration of substitution to do definite integrals. So our goal will be to do something like, how would you integrate something like the integral from 0 to 1 of 2 over 1 plus x dx. All right, so what is this equal to? And so you'll have to use integration by substitution. Right, but you have to actually worry about these limits of integration. They'll actually change when you make a substitution. All right, so we're back again, and we're talking on 5.4, an integration on substitution. And what we want to talk about is how we can use the fundamental theorem of calculus to solve these types of integrals when we have limits of integration, when we have numbers here. So let's write down something here. So using the fundamental theorem of calculus. And let's just do an example of how this works with using substitution and the fundamental theorem to do a definite integral. So here are some examples. So use the fundamental theorem. I'm going to call this example 3. Let's continue on with the last lecture. The fundamental theorem of calculus to evaluate the following definite integrals. And that should not be capitalized, but it is. So part A, this is the integral from 0 to 1 of minus 2x e to the minus x squared dx. And this is not one of our 4 types. Okay, it's not a constant. It's not just a power of x. It's not just e to the x, and it's not 1 over x. So we can't integrate it. So we have to use substitution. So we're going to let u be equal to, and you have 2 choices really, minus 2x or minus x squared. If you choose minus 2x, you would be wrong. But if you choose negative x squared, you'll be right. So the idea is you can let it be the thing on the inside. So if you realize that's the thing on the inside, let it be it. Or you can say this is a function and its derivative is right here. So when you take the derivative, du is equal to minus the 2 comes down, you get negative 2x dx. And so I can, plug back in over here. But before I plug back in over here, I need to change these limits of integration because these are really x stuff. And if I substitute back in, I change it to u stuff. So I have to change this 1 into u stuff. So the idea is use a function of x. So u of 1 is equal to, you plug 1 into x, this is minus 1 squared, which is minus 1. And then if you plug in 0 for x, right, so you have u of 0, which is equal to minus 0 squared, which is equal to 0. Right, now, I can change my limits of integration. The lower limit is 0 still, but the upper limit becomes negative 1. And I have, let's change colors here. I have my u, right? This is my u, right here. So I have e to the u. And minus 2x dx, right? That's just right here. So that's my du. I can integrate e to the u. It's one of my 4 types, so it's just e to the u. I don't need to write plus c because it's a definite integral, so it goes from 0 to negative 1. And so I plug in the upper limit, which is e to the minus 1, and I subtract off, so minus e to the 0. And so that's equal to 1 over e minus 1. And that's my answer. Now remember, you can check these with your calculator by graphing this function here, this integrand, from 0 to 1, and then taking the integral, and you'll see that it will be equal to 1 over e minus 1. All right, let's do another one, part B. On this one, I have the integral from minus 1 to 0 of 1 divided by 1 minus 2x dx. And so I'm going to let u be equal to 1 minus 2x. Then du is going to equal a negative 2 dx. Right, remember the derivative, constant is 0, and then the derivative of negative 2x is just minus 2, and I put the dx on the end. I'll have to change the limits of integration, so now use a function of x, so u of 0, so I plug in 0 for x, I get 1 minus 2 times 0, which is 1. And then u of negative 1, which this is equal to 1 minus 2 times negative 1, which equals 1 minus a negative 2. Okay? And that's equal to, of course, 1 plus 2, because negative and negative is a plus, so that's equal to 3. And so this is going to be equal to, let's change colors. So it's going to be equal to the integral from 3 to 1 of what? Of this thing, right, which is my u. Great. So I'll have 1 over u. Then I have a problem, though, because I have dx But over here I have negative 2 dx, but it's not really that big a deal because I can move over the negative 2 by dividing both sides by it. So this is du divided by negative 2 is equal to a dx. So this is du divided by negative 2. And so this is equal to then, this is equal to the integral from 3 to 1, and I'll pull out the 1 over negative 2, right, 1 over u du, and I can integrate 1 over u, it's one of my 4 types. This is equal to minus 1 over 2 ln absolute value of u. I do not need to write plus c because it's a definite integral going from 3 to 1. I plug in the limits of integration, so I get minus 1/2 ln absolute value of 1 minus a minus 1/2 ln absolute value of not 1 but 3, because I plug in the lower limit here. So absolute value of 3. And now this term is 0 because ln of 1 is 0, and then minus a minus is a plus, so what I get is plus 1/2 ln of what? Ln of 3, because absolute value of 3 is just 3. Now remember, I could write this slightly differently. I could actually write this 1/2 times ln of 3 is the same as ln of square root of 3. Right, so watch out for little things like this, right? The power I can move up here, right? If I multiply, I can move the power up, so that's 3 to the 1/2, which is really square root of 3. But this is a fine answer. But if it's multiple choice, it might be hidden. The answer might be hidden by writing as ln of square root of 3. All right, so let's take a look at the group work. So take out the group work again and flip it to the back side of that handout and number 2 and try part A. All right, so on part A, you're given the integral from 0 to 1 of 2 divided by 1 plus x dx, and in the end you should get an answer of ln of 4. All right, so pause the video for a little bit and try to work this out and see if you can do what we did above. All right, so hopefully you got somewhere on this problem. So you have first to make your substitution, so u equals, right? This is not one of our 4 types, all right? So you have to make a substitution. You really only have one choice, 1 plus x. Then du is equal to dx. And you have to change your limits of integration. So if you plug in 1 for x, you get 1 plus 1, which equals 2. And then if you plug in 0 for x, you get 1 plus 0, which equals 1. And so now I'm going to make my substitution. So this is going to equal the integral from 1 to 2. 2 divided by u. Okay, remember my 1 plus x. That's right here. That's my u. And of course, dx is just du. And so this integral is now one of my 4 types. It's basically, if you want to, you got to rewrite this. If you want to, integral from 1 to 2, 1 over u du. And then I can integrate it. So this is equal to 2 times the integral of 1 over u is ln of absolute value of u from 1 to 2. And so I can plug in my limits of integration. So this is going to be equal to 2 times ln absolute value of 2 minus 2 times ln absolute value of 1, right, which is the same thing as 2 ln of 2 minus 2 ln of 1. And remember, ln of 1 is 0, so that term's 0. And so this is just equal to 2 ln of 2, right, which is really the same thing as ln of 4 because you can take this number and write it on top. So 2 squared, so ln of 4. So both these answers are good. So 2 ln of 2 or ln of 4 is fine. Let's do the next one together. So in the next one, part B, we have the integral from 1 to e of ln of x cubed divided by x, and this is dx then. And we want to integrate this, so you're going to make a u substitution because, of course, it's not one of our 4 types. And you have 2 choices. You can let u be x, or you can let u be ln of x, the thing on the inside. And I want it to be ln of x. 1 is the thing on the inside, but the derivative of ln of x is actually 1 over x. So if you think about this, you can rewrite this and see that this is actually ln of x quantity cubed, right, times 1 over x dx. Right, we did this before. Remember, like if you have 3/4, you can write this as 3 times 1/4. It's the same thing. And now if u is ln of x, of course du is equal to 1 over x dx. Don't forget to change your limits of integration. So u of e is equal to ln of e, which equals 1. And then u of 1, that's the lower limit, is equal to ln of 1, which equals 0. So this is going to become the integral. Now the x stuff becomes the u stuff, so 0 to 1. This is my u, right, so ln of x here, that's my u. And then, of course, this 1 over x dx is my, right here, my du. So I have u cubed du, which equals u to the 4th divided by 4 from 0 to 1. So I plug in my limits of integration. So I plug in 1, so I get 1/4. Minus, when I plug in 0, which is 0 over 4, so that's just equal to 1/4. And so 1 over 4 is my answer for part B. Now you should have enough to do the next homework assignment, integration by substitution, part 2.